On today's lesson, we are going to be focusing on graphing something called a simple inequality. So how do we take x greater than 5 and graph it? So that's going to be the focus of our lesson today. And it's pretty straightforward. We've already done something very similar to this, which was graphing inequalities, but with two variables on the xy plane. This will just be on a simple number line, so it's actually easier. So again, definition for an inequality is pretty much says that something is not equal. So it tells us something is bigger or smaller than what's on the other side of the sign, the expression that's on the other side of the sign. So inequality is like an equation, but instead of being equal, it has one of the four signs that you already know and recognize. Just remember, it's a mathematical sentence that states two expressions are not equal. All right, so here we have just two of these things. One's an inequality on the left. The one on the right is an equality, because it's got an equal sign. And we want to know what is the difference between the two. So obviously it's a symbol. And more specifically, what's different about the two is the number of solutions. So one of these has only one answer and one of these has more than one answer. So how many solutions are there, to be specific? So there is only one number that can go on the equality on the right. 4 is equal to 4 and nothing else is equal to 4 besides 4. On the left side, x less than 4, we can have multiple answers like 2 is less than 4, -9 is less than 4, and I can keep listing a whole bunch of these, and there's actually an infinite number of answers I can put on the left here that would be less than 4. I can put something like 1.3 is less than 4, and if we start putting out the decimal numbers, that's going to be a whole bunch of other numbers we can add. So there are many, many, many answers, or we say infinitely many solutions that we can have. So in this case, how do we now get to our objective, which is how do we represent the solutions? We go ahead and graph them, because we cannot list out every single answer for this right here. Like we said, there's an infinite numbers. I know there's going to be 3 and 2 and 1 and 0. All of these numbers are smaller than 4, and all the decimals in between. And we can also have 3.5 and 3.6 and so on. There's tons and tons of answers. So the way we represent all these answers, or this collection of answers, or this set of numbers, which is the formal way of saying it, is we graph them on a number line. And this will indicate everything. The number line indicates all numbers, all the numbers in between, all the decimals, all the fractions, everything. Let's look at one more example like this. It's not in your notes. This one is very similar to the previous ones. Again, the one on the right has one solution. The one on the left has an infinite number of solutions. But this one has actually one more solution than the previous one, even though there's an infinite number. The equal sign here adds one more answer, which is a number -2. And then everything that is bigger than -2. So like -1 and 0 and 1 and 2 and so on, right? All these answers, but this negative also includes the number -2 as an answer, whereas if that equal was not there, -2 would not be an answer. But there are still an infinite number of solutions here. And we still graph it the same way. So now in your notes, you have this right here, this sentence. When we graph less than or greater than, we use open circles to show that the number is not a solution. So this kind of goes back to when we were graphing on the XY plane, and we would either do a broken line or a solid line. For the less than or greater than, we would do broken lines. For the less than or equal to, greater than or equal to, we would do solid lines. It's the same idea, but we're not graphing a line, we're graphing something on the number line. So we use something called an open circle. So this is what it's going to look visually. You have the example x less than 3. Let's write down x is less than 3. Write that down, please. Pause it if you need to. And in order to graph it, we look for the number 3 on our number line, and we put an open circle at that spot. That tells me 3 is not an answer that would be true for this statement. So 3 is not less than 3, so we cannot say it's an answer. We use an open circle to say not an answer. Then we just color everything to the left. This says every single number that's highlighted is an answer. Again, that's the infinite numbers that go on forever. Let's try another one. X is, in this case, greater than -5. Write that down on your paper. Pause if needed. Now we're going to go ahead and put a circle on the number -5. That tells me -5 is not greater than -5, so we cannot count it as an answer, but we can count everything that is to its right. So that's pretty much how we graph a simple inequality. Just open circle, right or left, when we have a greater than or a less than. So how does it look when we have the other ones with the equals on them? So in this case, we use something called a closed circle or a solid circle. And that tells me that it's part of an answer. It's one more additional answer to the set of answers that are to the right or to the left of the number. So let's look at our first one, x less than or equal to 8. Write the phrase out. Pause if you need to. So we're going to go ahead, look for the number 8. We're going to put our circle at that spot, but this time we are going to shade it in or close it. That tells me 8 is a valid answer. 8 is less than or equal to 8, because 8 is equal to 8. So that includes the number 8 as part of your solution set. And then we just put our arrow to the left. And we're done. Last one of these on this little section, x is greater than or equal to -5. Let's write down the statement, x is greater than or equal to 5. We're going to put a circle at our -5. We're going to close it because of the equals, it's included. And we just shade to the right. Greater than goes to the right. So that's the general idea. Open, close circle is your big decision, and then left or right, where are my answers at? Let's go ahead and move on to the next few examples. So these are just a few more I want to throw in, because again, this is pretty straightforward, nothing too difficult. The only thing you got to watch out is for ones that look like this one, where you should notice that it's backwards. And if you are not careful, you may potentially graph it incorrectly. Just easiest solution to this is just flip it over and make sure you flip your inequality. So just write it as x less than -8, and then go ahead and graph it like we did before. So how do you write this out? Just when you have a blank number line like the one you have, you're going to put your own tick marks on it if you need to be. You're going to put the numbers on there, make sure they're in order on the number line like they should be. So in this case, x is less than -8. We're going to start with a -8. We know -7 is to its right and -9 is to its left. Remember, everything's backwards with the negatives than what you're used to with the positives. We're going to decide open or close circle. In this case, we have we said open, you're correct. Does not include -8. Less than means shade to the left. All right, and that's pretty much it. Let's try 2 more examples. Same thing here, it's backwards. Be very careful with these because people tend to make mistakes on these. Flip it over. Again, ask yourself all these questions. How do I write this? This is x. Always start with the x. X is greater than or equal to 12. We're going to label 12 somewhere on this number line. It doesn't have to be in the middle, but that's kind of where I put it. Put the 11 on the left side, put the 13 on the right side, and decide if it's an open or closed circle. In this case, it's if you said closed, you're correct. Shade right or left. If you said right, you were correct. And then just make sure it's completed, it's legible, and we're good to go. Let's go ahead and move on to example number 3. So here we're working backwards. I'm giving you the graph on the number line for the simple inequality, and it's your job to write down the expression. So here we see our circle is at the number -7, and it's going to the right. So right gets bigger, so that's greater than. It's an open circle, so it's not including this -7, so it's just strictly bigger than -7, so there's no equals here. So my statement would be x is just greater than -7, no equals here. So then just write down the statement, x is greater than, and I made a mistake on that, as I can just notice right now. So let me just fix it. It's just strictly greater than -7. And that's the answer for that one. And we're going to move on to number 4. So in this case, our number line is focused on the number 2, but it's going to the left. So that's getting smaller. That would be less than. And since it's a closed circle, it's including 2 as part of the solution set. So let's write it out in words. X is less than or equal to 2. And then we just write that. And again, I made a mistake on this one as well. So it's x is less than or equal to 2. And we're pretty much done with all the examples. Actually not, I'm lying. So now we're going to go ahead and just solving an inequality means finding all of its solutions. A solution of an inequality is a number which, when substituted for the variable, makes the inequality a true statement. So if you plug it in, if it's true, it's fine. So here are some words that give you hints as to what the inequality symbols you would use based on certain vocabulary. Those are just the definitional words. Another word we can use for less than is fewer than. Pause as needed. Another word that can be used in a word problem to indicate greater than would be something like more than or exceeds. Again, these are not all of them, but these are the general ones you might see. It's the next two that are the ones that have the ones that you see more often. So for less than, you can also use no more than. So even though it says the word more and it's a less than symbol because it's saying no more than, so you can't pass this amount, so it's everything and below. And at most, so it's saying, again, it's the opposite of the less than because it's saying it's like a barrier. It cannot go any higher than this, so it should be this and below. Same thing for the greater than or equal to. It's the same two phrases but backwards. No less than and at least. So these are just some general terms that we would see. So we're going to do 3 quick examples on that. So we have our first one. Anthony is shopping for a birthday gift for his cousin Robert, who has $25 in his wallet. Write an inequality that shows how many dollars he can spend on the gift. So I want you to try all 3 of these actually, and pause this, and then come back and look at the answers. So now that you've actually thought about the answers or written something down, let's go ahead and see what you got. So we're going to write an inequality that shows that Anthony has $25 in his wallet, right? And we want to write it as so. A is less than or equal to 25. So again, he does not have more than $25. And we want to have the equal sign because we want to include the number 25 on there. So he can spend the 25 completely, or he can spend less than 25. Let's look at the next one. Teresa is only allowed to swim outside if the temperature outside is at least, so again, that's my key word, at least 85 degrees. So write an inequality that shows the temperature in degrees Fahrenheit at which Teresa is allowed to swim. So it has to be at least, which is a minimum of 85 degrees. So is it going to be 85 and greater she can swim, or 85 and below? Again, at least is a minimum, so it needs to be 85 or higher. So in our case, it's going to be T has to be greater than 85, greater than or equal to 85 degrees. So again, I use the letter T for temperature. You can use any letter. Last one, in order to achieve an A in math, Ivy needs to score more than 95% on her next test. Again, more than means greater than. So this one's pretty easy. We just have I has to be greater than 95. So it cannot include 95 because it has to be bigger than 95%. So 95.1% and so on. So that brings us to the end of our lesson. We'll be having an exit ticket as soon as I'm done giving the whole class lesson. So go ahead and start working on the practice problems, and see you in a few minutes for the exit ticket.